Hello, everyone. Welcome to the second talk in our World Space Week events. And this has been our first time conducting World Space Week events, and it was initiated by AstroSoc, and we are thankful for our collaborating societies, which are Space Society, WISE, and SatNav from the University of Birmingham. Today, we are delighted to welcome Dr. Sean Elvidge from our university's Serene group, which is Space Environment and Radio Engineering. And thank you very much for joining us today. And this was a very enlightening talk and was a quite neat little follow-up to our talk on Monday. While we wait for questions to appear on the Zoom Q&A, I'm probably going to head to the YouTube chat. And we have a question from SpaceSoc, and they've asked, with the new satellites providing more radio occultations, what change will it bring to day-to-day weather predictions?
Yeah, that's a good yet hard question that I don't know very much about. I mean, so I think adding radio occultation data gives you a way of measuring water vapor in the lower atmosphere, and apparently that's incredibly important for making weather predictions. So I think that I think it'll likely have a really big impact because, well, there's two ways to think about it like this, is that currently the Met Office and people all over the world have to do regular routine launching of like weather balloons to go and collect some data and do bits and pieces like that. This is a data set that you can, enhance those forecasts, which obviously we all want, and you can get it again all over the globe. You can't release a weather balloon somewhere where you don't have any land to release it from. The idea of how big of an impact it will have is, whilst I can't quantifiably say how big it is, it clearly must have a massive impact because these companies have decided to exist, build satellites, launch satellites, which aren't cheap, so they can sell data to to weather providers. So the only reason you're going to pay a lot of money to buy this data is if it really adds skill to our modeling capability. So I don't know of a good answer quantifiably how big an impact it has, but I imagine a pretty substantial one in terms of certainly forecasting, again, because it's about getting data where you currently don't have some, assuming that we have things like winds, things that are going to move, they don't stay in one place, weather systems. So if you can model them better over here, you can predict it better if it's moving in that direction. So I imagine quite a big impact.
Perfect. Thank you very much. While listening to your talk, one thing that really caught my attention was the idea of the geomagnetically induced currents. That's something that was new to me, and I found that really interesting. I was wondering, are there any techniques that people could employ to perhaps study or observe these GICs from their backyard, for instance? Is there any sort of like experiment or home-based experiment that people could do to observe this in action?
Yeah, there is actually. Well, I mean, it can be fairly tricky. I mean, GICs themselves, I mean, the geomagnetically induced currents require, big, long runs of cable usually for the the longer the runs, the worse it can be. So you don't get that in your back garden as such, but what you can see is you can detect these fluctuating magnetic fields. So obviously the magnetic field around the Earth sitting there, as a CME or something hits the side of it and causes those fluctuations, you can have home-built magnetometers to look at those changes. And in fact, the BGS, the British Geological Survey, they have something, I think, on their website about building your own pretty cheap, straightforward magnetometer, which can detect these observations, which would be a cool thing that you could build yourself and see those impacts. Probably a good time to get into it now, actually, because the solar cycle is just starting to, we've just been in a minimum for a while now, it's just starting to pick up. So I think long term, over the next couple of years, we'll probably have more and more of this activity. So yeah, there are some homemade sort of things that you could do in the back garden if you were. It'd be quite fun, actually. I've never done one myself. I've seen the instrument. It's only about yay size. It's not very big, but that'd be quite interesting.
Perfect. We have one question in the chat, and as a side note, unfortunately, Space Society has to leave the call right now as they have another commitment at 4. But I'll ask the question that they've just asked. I think this is a question that's following up from your previous answer. And the question is, what type of organizations are interested in buying this data?
Yeah, so buying the radio occultation data. So that's actually a really interesting question, which I'm, again, not qualified to answer on, but I'll give you my thoughts here, is that what they would like, I think, people to buy is, say the Met Office or the American equivalent, or every nation's got their own Met Office equivalent really for predicting the weather. I think what they want is those organizations to buy the data to then use that in their models. The problem is there is some agreed international policy that weather data is going to be freely available. So if I collect some data in the UK, we have signed up to an agreement that says I will share that freely with other nations. And so the idea of buying weather data is sort of a bit contradictory to the current status quo of how that works. So I think what they would like are weather organizations, governments fundamentally, to buy the data. And how we get over sharing that so everybody in the world has access to it, I think, is one of the questions that needs to get asked over the, well, I would say over the coming years, but realistically, as soon as possible, people are going to have to start thinking about that. And the other option is, of course, if you don't get anyone to buy the data, then the companies themselves which own the data could make some models, and they can then output those weather data themselves, and then you can sell the product. I'm sure many people would pay money for a very accurate model of when it's going to rain. Now, I think our current work from the Met Office is very, very good, don't get me wrong. But if you could prove that I have a better way of predicting when it's going to rain, I think people would pay for that, let alone big organizations.
Perfect. I feel like, that was quite a comprehensive explanation. And in today's world with information overload, it seems as if information is more valuable than physical objects than ever before. So that was a
Absolutely.
very, yeah, perfect. Um, Seeing as to that we have already reached near about 4 p.m., which is tentatively the ending time of the session, I will probably go to the concluding questions that I had planned. If there are no more questions on the YouTube chat or in the Zoom chat, perfect. In the section where you were talking about the low boundary winds and you showed that beautiful animation, I noticed that there were sort of circular emanating ripples along the surface. What causes those ripples? They looked extremely mathematically satisfying.
Yeah, absolutely. So the important thing there is that, well, they're sort of random. In the instance that there's not some beautiful, clever reason for why they exist. That wind video is model output, so that also helps keep things mathematically tidy. But likely what you have, I think it works as you would have guessed, like dropping a stone in the ocean, is that when you get some event which causes some wind, whatever that might be, and you have some center point, it just emanates out in all directions. So it literally is just that rippling effect. Some weather phenomena happens at 100 kilometers that makes some wind. It has to dissipate somewhere, and it just dissipates itself pretty equally across the globe. So you get that circular pattern.
Perfect.
Nice
Thank you
video.
very much. Thank you. And this question is actually a question that I asked to our speaker on Monday as well. And it's basically to do with CubeSats, Starlink from SpaceX, and the Kessler syndrome. The Kessler syndrome is one of my personal favorite topics. In fact, I'm also going to be giving a talk about it tomorrow, so I was curious to know what your opinions would be about this. With the upcoming technologies of CubeSats, while they are incredibly advantageous with the sort of range of areas that they cover, or just with the amount of sheer power that they have to revolutionize internet all across the world, they do come at the cost of potentially increasing space debris and being viewed as a sort of like pretty much pollution in a way, especially with the recent, sort of, I would say, like, sort of fiasco that they had with regards to like astrophotography and trying to picture the comet, and the Starlink CubeSats came in the way. I'm just curious to know, what are your opinions about the increasing uses of CubeSats with regards to space debris?
Wow, that is a question. Um, so, so space debris is clearly a major problem. It's a major issue. I think, I mean, you said it right in terms of pollution. I mean, it's a major environmental impact that is not talked about as an environmental impact primarily. So, I mean, part of the work that we are looking at doing right now, or a project we recently started with the Met Office at the University of Birmingham, is to look at exactly this kind of question, which is, space debris, can we better model where it's going to be? We worry about the Kessler syndrome, sure. We know that we're at a point that the number of launches are increasing at a crazy high rate. The number of satellites is going up at a crazy high rate. The point of no return is basically gone, in that even if we don't launch any more satellites today, there are enough already up there that we're going to have some form of major collision event at some point. So we can't just solve the problem by doing that. Okay, some measures have come into things like the 25-year rule, and things like that for bringing satellites back down will help, I'm sure. But there's all this, I mean, although there's very impossibly to enforce that rule anyway. I think you sign a bit of paper that says you'll do it rather than enforce it. And so what we want to do is, the key, I think, becomes trying to model where things are going to be. That's, I think, the key attribute for dealing with Kessler syndrome, space debris. And the other thing is, just by having sensible policy decisions based around where we should let satellites go to. So obviously in the UK, we have a particular interest at the moment with OneWeb and our partial acquisition of that. And a lot of analysis has been done on where should they sit, sort of what orbital heights would be, sensible, where they can still do the job we want them to do in terms of, let's say, communications, but not be in a really dense region as well. Space is pretty big. We've got lots of it. And so if you have a mixture of good long-term planning of the constellation, as well as clever altitudes where you should place it, then I think we can have a growing number of satellites without it being too detrimental. What I would say is that a guy we're currently working with is really excellent at this stuff, is Professor Hugh Lewis from the University of Southampton, who, just for anyone, I highly recommend just follow his Twitter account, who often talks about space debris and modeling, and he's done a lot of that kind of work and explains it in a non-alarmist way. The problem with Kessler syndrome, it's very easy to make out that the end of the world is just around the corner, or at least the end of our space world. And we have to not, go over the top, otherwise people won't believe us. You can't cry wolf too many times. So it's about getting the right balancing act. But fundamentally, it is a huge thing that we need to address, and hopefully being able to better model where these satellites are going to be is a way to try and mitigate that kind of Kessler syndrome impacts. I saw that you were giving a talk on Kessler syndrome. Otherwise, I thought about including some more slides about it, but I thought I'll save that for your discussion.
No worries at all. I'm sure any information you'd provide would probably be far more detailed and scientifically rigorous than mine would have been. Excellent. Well, I mean, on Monday when I posed this question to Dr. Thiemens, he did mention to me and highly recommended that I should ask this question to you, and it was fully justified. And I'm really thankful for the thorough explanation you gave. And honestly, I feel like one of the things that today's generation needs to be aware of in terms of satellite technologies is that it comes with a price that someday everyone might have to pay for, even if we are not directly linked to it. And the more we can do for the awareness of it, I guess the better.
Yeah, I mean, I think the colossal number of satellites that things like Starlink talk about is hard for most people to comprehend, because they don't have a good feeling for how many satellites we currently have there. So if you talk about launching 40,000 satellites, let's say, to a random person, though, that might not seem like a large number. They've got no scale.
Mhm.
But if you say, well, actually, we only have about 2,500 active satellites currently in that regime, then you're talking about increasing that by a factor of 16. Then actually, okay, maybe you can start to see that that's why people are talking about it. And it's the same with the astrophotography thing. I think that there's potentially huge impacts from astronomy and astrophotography, but we also have to do it be carefully. I've seen some images where people have compiled, they've combined lots of Starlink passes all together over the course of a night and shown one image with about 40 lines going across it. Now
Right.
that's not really what you see. Now
Yeah.
if you're doing long exposures and you get that, fine, you can show that, but let's not exaggerate the problem, because then when people find out the truth, they can be put off by it. So we've just got to approach it. And like you said, we want some of the advantages of the satellites. So we can't just get rid of them all.
Mhm. Yeah.
So we need to just kind of come up with some compromises that work for both communities, which best comes from chatting to people, really.
Thank you very much for that perspective. And yeah, I had not thought about the astrophotography aspect from that perspective with regards to it perhaps being like a chance occurrence and that being highlighted more in the news and the media. But yeah, it's nice to have a better rounded view of it. Thank you very much.
Although I should add, I mean, if you had 40,000 Starlink satellites and then 40,000 OneWeb satellites, then you do get that kind of, you would get that crazy covering in the sky, I'm sure.
Perfect. Well, that would probably bring us to a close of the session. And once again, thank you very much for joining us. And we are delighted to be able to host you. And in the future, should we have more upcoming events, we would love to invite you again.
Absolutely, yes. Thanks very much. Thanks for inviting me.
Perfect. And for all our viewers, thank you very much for joining in. It is your very continued support that keeps us going and keeps us motivated to bring more such events for you. And do stay tuned to all of our social media pages, and we will be posting updates about all of the rest of the World Space Week events we have planned for you for the rest of the month. Perfect. And I hope to see you again tomorrow for the next talk. And happy World Space Week, everyone.